Okay, next thing we are going to review is how to solve a quadratic equation. There are 4 different methods, all of them you've learned before, so this is review. Hopefully it'll be enough to jog your memory. First of all, I want to review when I say quadratic equation, so I want you to write this down. I mean that the highest power is a 2. Highest power is a 2. So we are looking at equations where the highest power or the highest exponent is a 2. There are 4 different ways to solve these equations. We can factor, we can do the square root method, quadratic formula, or completing the square. One thing I want you to know, for both factoring and the quadratic formula, so for both of these methods, the equation has to be set equal to 0. For square root method and completing the square, that's not the case. But if you're factoring or doing quadratic formula, your equation has to be set equal to 0 before you do anything. Okay, so let's jump into our factoring. Our equation is set equal to 0. That's a good start. So now we are going to factor. There's no GCF, so remember, always start with the GCF first. We don't have a GCF. In this case, because of the 6 out in front, we are going to have to split the middle. We are looking for 2 numbers that multiply to negative 72 and add to 1. Remember, this 1 comes from the middle term, that 1x. What are those 2 numbers? 9 and negative 8. We have to split the middle. We cannot go to x plus 9, x minus 8. Because of this 6x squared, we have to rewrite that middle term. So this becomes a 9x minus 8x. The order doesn't matter. If we wanted to swap it, we could. First term comes down. Last term comes down. And now we are going to factor both sides. So we're taking a GCF out of both sides. On the left side, 6x squared and 9x, I can take out a 3x. And when I do, I'm left with 2x plus 3. On the right side, I have a negative 8x and a negative 12, so I can take out a negative 4. When I do that, we get 2x plus 3. So remember, if we're doing things correctly, the parentheses should match. If they don't match, then we did something wrong. Our first factor is 2x plus 3. What's outside becomes the second factor, so that's a 3x minus 4. We are not finished because we have that equals 0, because we are solving. So at this point, what you're going to do is you will set both of those equal to 0. So 2x plus 3 is equal to 0, and 3x minus 4 is equal to 0. If I subtract 3 and divide by 2, I get x equals negative 3 over 2. And then if I add 4 and divide by 3, I get 4/3. Those are my 2 answers. How do I know from the beginning of the problem that I'm going to get 2 answers?
Exponents.
Jack, thank you. Exponent. Look at the highest power. That tells us that there will be 2 answers. I cannot stress enough, when you are factoring, it has to be set equal to 0. If it's set equal to something else, you're not solving by factoring. Okay. Second one, we're going to do quadratic formula. If you remember, quadratic formula has to be set equal to 0, which ours is. This is the one where you have the A, B, and C. Quadratic formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so then if we do that with the problem we have, b is negative 4. So the opposite of that is positive 4. Plus or minus the square root of negative 4 squared minus 4 times a times c all over 2 times a. Students tend to set quadratic formula up correctly, but make mistakes because of either order of operations or their notation. So like we talked about 2 days ago, that negative 4 needs to be in parentheses when we square it. Order of operations wise, I'm going to do everything underneath the square root first. So I get 4 plus or minus the square root. Negative 4 squared is 16. Here's where we need to be careful. I don't like dealing with that negative 4. So what I normally do is think of this as adding a negative. So now I know that I'm adding. And I know that I have 4 times 4 times negative 1. 4 times 4 times negative 1 gives us negative 16. Okay, so then this becomes 4 plus or minus the square root of 0 over 8.
Wouldn't it be 16?
It's positive 16. Thank you for stopping me. This should be a positive 16. Negative 4, negative 1, positive 16. Thank you for catching that. So then underneath that root, we actually have a 32. You cannot divide by 4 here. That's what everybody wants to do. They want to divide everything by 4. You can't. You have to simplify the square root first. You have to simplify the square root first. I'm going to do that over here. So 32 is 8 times 4. This is 4 times 2, then 2 times 2. And this 4 is also 2 times 2. Because it's a square root, you're looking for pairs. So I have a pair of 2's and another pair of 2's. Each 2 comes outside the root, which gives us a 4. This 2 that's left goes underneath the root. So, almost done. We get 4 plus or minus 4 root 2 over 8. And now I can simplify. 4, 4, and 8 are all divisible by 4. So if I divide by 4, I get my x to be 1 plus or minus root 2 over 2. Sorry, I didn't give us a lot of room. So this root 2 just stays root 2. Remember we talked about x squared, there's going to be 2 answers. We do in fact take 2 answers. 1 plus root 2, 1 minus root 2. Questions before we look at the next 2 methods? Okay. Square root method. The objective here, you want to get that part that's squared alone. So we need to get rid of the 18 and the 2. We're going to move the 18 over. So we get 2 times the quantity x plus 4 squared equals negative 18. Can we do a quick mass check for people who do not have a mask covering their face? Divide by 2. So we get the quantity x plus 4 squared is equal to negative 9. So that was step 1. Get the part that's squared alone. To get rid of the square, I can take a square root. What do I have to remember anytime I take a square root? Plus or minus. So anytime you take a square root, you should get plus or minus. The square root of 9 is 3, but because it's a negative 9, that gives us an I. And lastly, we move the 4 over. So we get negative 4 plus or minus 3i. Those cannot be combined. One has an I, one doesn't. Please note common mistakes here. What some students do is they get all the way to the end, then they put the plus minus. As soon as you take a square root, you need the plus or minus. You can't just add it on at the end. Okay, last one is completing the square. The idea with completing the square is we want to get to the point where we can use the square root method. What you're going to do is you are going to leave the x's on one side. Everything else you're going to move over. So this -5 is going to move to the other side. So we get x squared plus 8x. You're going to leave yourself a space to complete the square. On the other side we have a 5, and we're also going to leave ourselves a space. Okay, in order to complete the square, what you're going to do is you're going to take that b term, you're going to divide it by 2, and you're going to square it. So 8 divided by 2 is 4. 4 squared is 16. So 16 is what we add to both sides. Okay, now on the right side we get 21. If we do things correctly, the left side should factor. Looking for two numbers that multiply to 16 and add to 8. It's 4 and 4. They should be the same. So this side then becomes x plus 4 squared. Again, they should be the same. Two numbers that multiply to 16 and add to 8, 4 and 4, they should end up being the same. Take a square root. So we get x plus 4 equals plus or minus root 21. Don't forget the plus or minus. And lastly, moving the 4 over, we get -4 plus or minus root 21. Again, those cannot be combined. Put the plus or minus as soon as you take a square root. In your homework, you might be told use this specific method, in which case you have to use that method. If you're not told, you can just choose whatever method you want. Questions before we keep going? Okay. We have another one to solve by factoring. We're going to do this one real quick. First step to factoring always is what? GCF. Out of these two terms, I can take out a 2 and I can take out an x. When I do, I'm left with x squared minus 4. I forgot to ask, how many answers are we going to get in this case? 3. Okay, x squared minus 4 does factor. So you need to keep factoring. X squared is x times x. 4 is 2 times 2. 1's positive and 1 is negative. Don't forget that 2x that you took out. Remember, if it was adding squares, it wouldn't factor. And then you would set all 3 to 0. So we would get 2x equals 0, x plus 2 equals 0, and x minus 2 equals 0. Are you okay if we just leave it there and keep moving? That was the most of the problem. Example 3 is a little bit longer, that's why I want to make sure that we get to it. Example 3, you are solving the rational equation. That just means that it has fractions. Okay, here's your basic idea. You're going to factor all the denominators if you need to. Then you're going to multiply every term by the lowest common denominator and solve. You have to check your solutions, and I will show you what that means. Okay, I do things a little bit differently, so I'm going to show you what I do. In this case, all the denominators are factored. We don't need to do any more factoring. We are trying to get every denominator to be the same. We'll notice this fraction has an x plus 4. That means that this one is going to need an x plus 4. So that first fraction needs an x plus 4. So you multiply both numerator and denominator by x plus 4. This first fraction then has an x plus 4 and an x minus 3. Second fraction has the x plus 4. It needs the x minus 3. So that second fraction needs an x minus 3. You will multiply then by x minus 3. And then the last fraction has the x minus 3. It needs the x plus 4. And here's where we're going to start multiplying. The denominators we are going to leave factored. The numerators we're going to actually multiply though. So I'm going to distribute this 2x, and I get a 2x squared plus 8x. And then my denominator is x plus 4, x minus 3. The second one, I have to multiply x plus 1 and x minus 3. So I have to multiply these two. I'm going to do it over here. X and x is going to give me x squared. X times negative 3 gives me a negative 3x. And then I have a positive 1x and a negative 3. Combining like terms, this becomes x squared minus 2x minus 3. So this is x squared minus 2x minus 3 over x plus 4, x minus 3. I'm going to erase that just because I didn't give myself a lot of room. Last fraction has an x plus 4 and an x minus 3. I need to multiply the numerators. Are you all okay if I just tell you what we get without showing you the work? Okay, you end up getting x squared plus 3x minus 4. Okay, why did we get a common denominator? On the left side, I can now add those fractions. So the left side, I can now add these fractions because they have the same denominator. So that's what I'm going to do. 2x squared add an x squared is 3x squared. 8x minus 2x is a 6x. And then I have a negative 3. Right side I'm going to leave the same. Now I have two fractions set equal to each other. If the fractions are equal and their denominators are the same, the numerators have to be the same. That's the only possibility. If you think of something like this, 1 over 2 equals x over 2, denominators are the same, numerators have to be. You would get x equals 1. In this case, denominators are the same. That tells us that these numerators have to be equal. Stick with me. We're going to be done soon. Move the x squared over. Well, you're moving everything over, actually. Three x squared minus x squared is 2x squared plus 3x plus 1 equals 0. Okay, in this case, you can solve how you want. I'm going to tell you that it factors. You okay if I just factor it for us? We would need to split the middle, but I will just tell you. It ends up being 2x plus 1 and x plus 1. So setting both equal to 0, we get x equals negative 1/2 and x equals negative 1. We're not quite done. Okay. You do have to check your answer. Here's what I mean when I say check your answer. So please write this down. Check your solution means that the denominator cannot be 0. So what you're doing is you're taking your 2 and making sure we don't get any denominators that are 0. If we take -1/2 and plug it into all 3 denominators, we don't get 0. If we take -1 and plug it into all 3 denominators, we don't get 0. We're good to go. I don't expect you to write anything. You can do it in your head. Is that clear? Okay, there's one other thing I forgot to tell you. Any questions before I tell you the last thing I want to tell you? Okay, I do want you to write this down because students sometimes forget this. With completing the square, has to be a 1x squared. In your quadratic equation, you have to have a 1x squared. So if we were looking at what you did in B, which was this one, 4x squared minus 4x minus 1, you can't complete the square there. Completing the square has to have a 1x squared.